In this tutorial, I will introduce dialog boxes. They're a fun way of making the program a little more interactive for the user, but be aware, it takes a little more programming in the back. A few vocabulary and punctuation. Recognize the different input and output dialog boxes that exist and correctly use the dialog boxes in cell arrays. Now remember what cell arrays are. They are a type of MATLAB arrays that contain cells with data of any data type. So I can put numbers, I can put strings, I can put vectors, I can put another cell array in there. And the reason why we bring them up here is because a lot of the dialog boxes deal with cell arrays. Whether they need them as arguments or they return a value like that, they're definitely involved dramatically with cell arrays. Dialog boxes, what are they? Well, they create dialogues between the user and the application through the use of little pop-up boxes that pop up on your screen. Whether they're error messages or prompts, they're just a little more fun. Now there's two types of dialog boxes, modal and non-modal. A modal window will be one that requires the user to interact with it before the program continues. So before the application continues on to what it was doing, it's just going to wait and wait and wait and wait for you to do something with whatever just popped up. The opposite is non-modal, and this one is one that just pops up a little window but then continues anyway. So maybe if there's another result, it'll pop up on top of it. Or if there's a figure, it pops up on top of it. So that's non-modal. A quick way to remember it, non-modal means non-waiting. So it's kind of negative, negative. We are going to have to learn a couple functions because everything with dialog boxes has to deal with strings. We're no longer really going to be using numerical values at any time. And if we want numerical values, like if I type in 234, MATLAB actually is going to see it as a string. If I want to convert it, I'm going to have to use string to double, str to double. sprintf is kind of the opposite. Sometimes I'll have number, but the dialog boxes needs a string to work with. So that way I need to convert the other way. That's one way of creating a string or formatting a data into a string variable. And sometimes some of those boxes that pop up, we really don't want them to be non-modal. We want them to wait. We want MATLAB to force the user to read the message. And in that case, we'll have to do something called UIWait to force the user to click on a box that normally just goes on with the flow. So here they are. Input DLG allows us to have multiple fields to enter values. But here I can already tell you that that 20 at the top is the word 20. It's not the number 20. If you want buttons instead, you have menu and quest DLG with 3 buttons only. Menu, you can have as many as you want. If you want maybe the user to click a list, you have list DLG. Or if you want a browser to open, you can have UIGetFile. Now there's a huge advantage to these. The ones on the right, for example, you can't possibly mess up as a user. You can't choose a color that doesn't exist. You can't say that you maybe want a dessert but not really. You cannot select a planet that doesn't exist. You cannot select a file that doesn't exist. You just can't mess up. The one on the top left, unfortunately, we can never prevent any bad entries. We can do loops, but right now, I would prefer the ones on the right. There's one disadvantage though. What happens when we have those X's that we can click cancel? How does the code know what to do when I hit cancel? Unfortunately, that adds a lot of if statements to skip stuff. So be aware there's advantages and disadvantages to using these things. Most of the input dialog boxes, and it does make sense, are modal. They will wait for the user to interact before it continues with the code. The opposite is the output dialog boxes. There aren't that many. One of them is message box and it displays a little message, but this one is non-modal. So meaning you can display as many messages, they'll pop up right on top of each other until the code ends. In that case, we'll use UIWait to force the wait. There are some built-in error DLG and warn DLG that you can use. That way you don't have to specify the icon in the message box. Now all of these, both input and output dialog boxes, are not closed automatically. So if you have a lot of message box and you don't close them, they're still going to remain there every time you run. Close all has no impact. So instead we use close all child 0. Try it yourself. Your first message box maybe. We just want to say hello world, so the argument is a string, and use single quotation marks. So it would look like this. And when I hit run, I have a little box. But if I don't close the box and I just hit run again, you'll have the box and the box and the box, and it looks like it's closing, right? Because you don't really see the old one. But if I go down here and show you, all the ones that I ran are still open. And that's what I meant by close all. If I just experiment, well, they're still open. So that's not good. So instead we're going to use close and as an argument all child, and as another argument inside of that 0. And when I hit run, then this one pops up, but if I look at what I have after, the other ones are gone. So we're kind of shifting away from figures into little dialog boxes. So here's our very first example. How much money is there if I have 2 quarters, 3 nickels, 4 dimes, and 5 pennies? I want to use one input DLG to ask for all of them at once, so 4 fields right there, and one message box to display the number. The algorithm, if you look at it, is not just straightforward prompt, calculate, call it quits. We're going to have to convert back and forth strings to number, numbers to string. The values that you see here, quarter, 2, 3, 4, 5, are actually words. The word 2, the word 3, the word 4, the word 5. Char data type. So before I can do the math, I'm going to have to convert them to numbers. And on the other side, the ones that you see here is the letter 1, period, 1, O. It's not the number 1.10. So we have to constantly go back and forth between these things, because that's what dialog boxes have in default. They have strings as arguments, as return values. It's always char data types. So the function we want to use to prompt is input DLG. Now the only way to learn these things is the documentation. So as soon as type the word, you press F1 and it brings it up. And you can see there's usually a couple ways to use them, from very easy to a little more intense, although we are actually going to use the 4th option today. The prompts always go first, just like input command. What do you want to ask for? But second, now that we have a box, we can give it a title. Third, the field doesn't have to just allow one line to be typed in. You can type in more than one line. And then if you want to pre-built in an answer, which is kind of hard coding a default, then it's the 4th option. And this one is really awesome when you're a programmer testing. The last thing you want to do is enter the values each time you run, so you predefine some kind of answers. But right now I'm kind of stuck in between, because I have 1, 2, 3, 4 prompts. I have quarters, nickels, dimes, and pennies. How do I put 4 prompt into one? Because I only have one spot for the prompt. If I start putting more commas in here, then I'm moving into these. That's when we use cell arrays. So if we read a little bit more of the documentation, prompt in the cell array. Prompt is a cell array containing prompt strings. So that's just using what we just learned, cell arrays, and then I can type each one of my words. Quarters first, I did nickels seconds, why not? And then dimes, and then pennies. So cell arrays. None of these words have the same dimension, so I cannot combine them into a vector or anything. Cell arrays. So that's my first argument. Title of the box, coins. The number of lines. So let me show you what that does. If I do 2, then you have 2 lines that I can use. I can type in a 3, 4, and I can enter actually strings, and it just continues. I have enough room for 2 lines. It's not what I wanted to do, but that's what that value does. I'll stick to 1. And then the default answer will come back to that. We'll call those the amounts. So now when I type in 2, 3, 4, 5, I I should have 2, 3, 4, 5. Sweet. Now, here is when it starts becoming interesting because you have single quotation marks. So that means that first of all, we have a cell array that has 4 containers, 1, 2, 3, 4, stacked on top of each other. When I go in there, and when I double click the first one to actually go see the first content, then you'll notice it's a char. It's the letter 2. So I can't possibly do math with that. I'm going to have to convert. So string to double and in parentheses amounts. So now when I do 2, 3, 4, and 5, I actually have no single quotes around them, and I directly have a numerical array, specifically a column vector. Okay, now if I convert it, I have to restore it. I definitely do not want to keep A and S. I'll call it amounts nums. I could definitely reuse the same variable. In case I want to keep the original strings, I won't, but if I didn't want to, I could do amounts and completely override the previous variables. So I'll have amount equal string to double amounts. Alright, so moving on. Let's calculate the sum. So I have a vector of 2, 3, 4, 5. If I had another vector with the actual value of the coin, then I could just do vector math, and that would be just one line of code. I wouldn't have to do anything fancy. So I'll call the coins to be 25 cents first. For nickels, it's 5 cents. For dimes, it's 1. And for pennies, it's 0.01. And then my money is equal to the sum of my amounts, nums, element by element, multiplied to that vector. Alright, this is where you're starting to see me. I don't want to enter these things. I wish they were there before. That would be awesome. As a programmer, I wouldn't have to do anything. So let's go do that. Here, I told you that we could add default answers. So I want the letter 2, the letter 3, the letter 4, and the letter 5 to be pre-entered. So once again, a cell array. The letter 2, the letter 3, the letter 4, and the letter 5. And by doing this, I will automatically have all of those pre-filled. All I have to do is hit OK. It goes so much quicker. And I do have $1.10, so the math actually works. Now I did have to use, again, a curly brace idea because I only have one argument for the default. If I didn't, then this would be argument number 4, 5, 6, and 7. And the documentation does not show me 7 possibilities. So this is one argument. I combine them together to be one single argument. Now as far as displaying the message box, you have dollars, 2 decimals, and then money. Yikes. Now it crashes because the argument of message box needs to be a string. If you look at the documentation again, you can have 1, 2, or 3, or many arguments. But I use the second one for what MATLAB wants as a title. So technically I want the title of my box to be $1.10. Doesn't make sense. So I really have to match that syntax that I'm shown. Everything related to that message needs to be my first little message, first argument. Now I can't combine it as a cell array. That would be an interesting experiment. And it crashes again. I want a string this time. So in this case, I use kind of what I had in the past. The fprintf used to combine all these things together. Except I don't want to print it down here. I want to create a string out of it. So I changed the f to an s. And MATLAB combines all these pieces like in the past, but now it stores it into a string. And that becomes my argument. And then it works. So notice, it was not just boom boom, prompt, calculate, done. Not anymore. We have to convert back and forth between numbers and strings, but it's a lot more fun for the user to interact with. So remember, close any open boxes first. Use curly braces for cell arrays. The fourth argument is one of the most friendly part of this code, so we don't have to enter values. String to double converts from strings to double data types. And then we have the opposite. We create strings out of numerical values using sprintf. Very similar example, but this time for you to get used to this syntax, it's a little bit overwhelming at first. Ask how many hours, minutes, and seconds, and then convert all that to the total amount of seconds. Here's the answer. You can pause if you need to look at it. Very similar to what I just did. Here are the most common syntaxes for each. So I've shown you input DLG, menu works the same way, quest DLG, they all really work the same way. List DLG is a little bit different, and I'm going to show that in another tutorial, where you can see on the left side this time you have two separate results possible. But please don't learn these things by heart. The only way I remember them is every time I need it, I go to the documentation. So press F1 as soon as you're on that keyword, or just wait for that little yellow box to pop up. As far as review, vocabulary words, we saw cell arrays, dialog boxes, and modal versus non-modal. Some of them will just show up and continue, and some of them will wait for you to work with. Punctuation, we saw close all child 0, string to double, and this printf. But we can recognize the input from the output. There's a lot of input options, but there's really few output dialog boxes. Just remember that they usually work with cell arrays and strings, so we kind of have to go back and forth between the two data types constantly.